Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video, and if you have not subscribed before, help us to subscribe immediately you see it on any of your device. Presently we have over 210 videos on our platform. It means you can come to this platform and learn any topic of your choice. And also we need your help. I'm not begging, but I need to beg presently. We need to buy a bigger board. We need to buy a standard camera, and also even having a marker to ourselves. No amount is more. We need your help. Just make your contribution. We surely appreciate that. To reach us, you can reach us on this number 2340034495990. With this number, you can call us. This number you can WhatsApp us also, and Telegram is allowed. Those are the things that can take place in those numbers. You can this number, phone numbers. You can call us, you can WhatsApp us, and also Telegram is allowed. Presently, please, no amount is more. And if you have any question to drop, you can reach us on this number, or you want to ask us any question pertaining to our service, we are also there for you. In this video, I'll be walking you through equilibrium of bodies in liquid. Equilibrium of bodies in what? In liquid. That is what I want to be working on this video. Okay, by the end of this video, you will understand all what you need to understand, like Archimedes principle and how to handle some problems under this part. And also, when you are watching any of our video, make sure you start from video 1, because we do it in series mostly. Make sure you start from the introduction part and move on till you get to where you are going to. Now, when we talk about I will start from Archimedes principle. Let's understand this Archimedes principle. Now, this Archimedes principle really helps us when it comes to equilibrium of body, which is we're talking about floating and other things. Now, the equilibrium force is okay. Before we move on to Archimedes principle, let me quickly explain some things. The equilibrium. Sorry, I forgot to equilibrium of bodies in liquid liquids is governed by Archimedes principle. And principle of the principle of floating. Yes, floating. Now, floating. These are the two things that this Archimedes principle and principle of what? Of floating. Now, once you understand these two things, Archimedes principle and the floating principle, you understand this also. Now, and closely related to this okay now, and also relative of about and fluids. Now, those are the things that we surely work on this part of our video, which by the end of this video you will understand it. Now, with this, let me now state Archimedes principle. Archimedes principle. Now, I'm now on Archimedes principle. Now, let me start with Archimedes principle. How do I state Archimedes principle? Please take note of this information I just wrote now. They are very, very important. Now, Archimedes principle. Okay, Archimedes principle states that when an object is completely or partially emerge. Okay, partially emerge in a its experience and upper citrus, which is equal to the weight of the fluid displaced by the object. That is the principle of what? Archimedes. That is Archimedes principle. Now, the second principle, we know it as floating, which is a principle of floating. Now, how do I say down? Okay, now, principle of flotation or floating. Anyhow, let me use the word flotation. Now, principle of flotation. Now, let us to know that principle of flotation states that an object will float when the decided upon it by the field in which it floats, its float is equal to the weight of the body. That is what we are talking about. Can you see the Archimedes principle and principle of floating? Now, with this, we really help us to know or how to handle problems on equilibrium of bodies in liquids. Equilibrium of body in liquids. But note that obtuse of objects in fluid equals to weight of objects in what? In air. In air minus weight of objects in fluid. These are these things that we need to find. It means I'm talking about my U of F equals to W of A minus W of what? Of F. That is, I just decided to denote that so that you can see it, which is that is what it's all about. Now, okay, let me quickly try to make some definition. Okay. Make sure that you understand this part very well before you go to the problem part. Now, notes. Take note of this information. That the fluid could be water, gas, or any other liquid. Therefore, U of F and U of W, W of F could be of water, and what? Of liquid. Now, that is just we are trying to say. And our citrus of object in liquid equals to, I would like to write weight of displaced fluid, which also can be equals to mass of displaced fluid, which is in gram, x gram, let me put x gram, and also density of fluid multiplied by volume of displaced fluid, which is x. Now, also can also be equals to density of fluid multiplied by volume of objects, which is which is gram. Now, it means I can say that my U of this equals to this multiplied by V multiplied by what? Gram. Now, very, very important. Now, let me make some analysis also so that you can understand this part very well. Density P is defined as the mass per volume of a substance. Measured in kilogram. Okay, that is what is measured with, measured by this. And also we should try to know about a relative density. Now, how do I make a relative density? My relative density, which is, I call it RD, is, relative density of a substance is the relative is the ratio of weight of any volume of its to be the mass or weight of an equal volume of water. Now, what I'm trying to say here is that my relative density of solid equals to mass of substance divided by mass of equal volume of water. Let me use H2O. Equal volume of water. Now, and also, I can also say that my relative density of solid can also be equals to weight of substance divided by density of water. Now, also I can say that weight of density of substance. Okay, I can also say that the density of substance divided by density of water. Also, I need to rub this part anyway. I can also say that also can be equal to my relative density of solid. Can also be equals to weight of objects in air divided by weight of equal volume of water. I can also say that weight of object in air can also be equals to obtruse of object in water. I can also say that now I think with this you can know what my relative density of solid is saying. Now let me move on to relative density of liquid. Relative density of liquid, which can be equals to, now this is of solid. All I'm giving you here, they are useful. When we are solving problems, we'll be using them one by one to explain all what relative is talking about. Now, and also I can say that equals to relative density of liquids, which is liquid can be any form. You know what liquid is all about. You know, you have to understand your state of matter very well. Anyway, now I can say that my obtruse of object in liquid divided by obtruse of objects in water. My H2 is water anyway, sorry for that. Now I can say that my volume of liquid displaced by object divided by volume of water. Volume of water displaced by same object. By the same object. Now, also, I can say that what thing can I say? I can say that apparent loss of weight of a solid in liquid divided by apparent loss of weight of same solid in water. Now, with this, I think we have done it very well. I don't know, maybe I should give one or two examples on this part before I have before we call it a day. Now, with what we have done, you can see how this is relative density of solid and relative density of what? Of liquid. We can see how this is being used. Now, when we are to solve problem now, we can call upon any of this to get our problem done. Okay, I would love to give one or two examples before I end this part, which is okay, let me give this one example, and after I will now come and the next video I will now work on problems on equilibrium of bodies in liquid. Now, this example is only example I will give. An object weighs 10.0 Newton in air and 7.0 Newton in water. What is its weight when immersed in a liquid of relative density 1.5? Now, that is the question that I want to show you. This is very cheap, very simple. But in our next video, I will solve more of which is it will be basically problems on equilibrium bodies of body in a liquid. Now, how do I solve this problem? It's a simple problem. Once you have those information at hand, any problem you have should be very simple for you. You are just try to relate it out. Now, the first thing I will do is that let me list out my relative density of liquid 1.5. That is first thing. The weight of object in air, which is WA, is 10 Newton. And also the weight of object in water, which is WW, is equals to what? 7.0 Newton, which is 7 Newton anyway. Now, also I can say that what am I looking for? What is the weight when in mind? Now, it means I will have weight of object in liquid, which is WL, is X. I don't know it. Now, which formula will I use? I want to know the best formula to use. Now, the formula will just be my relative density of liquid. It will be equals to. Now, I'll be working on the obtruse, which is of object in liquid, which is U of L divided by of object in water, which is a U of what? U of W. With this, I'm good to go. Therefore, what I'm just trying to do, this is relative density. My relative density, which is my relative density, equals to U of L divided by, now, of water. W of L divided by what? Which I've quoted here already. Now, since I have that, I can now say that, what is that? I have W of L, which is, I don't know it. I can say that 1.5 equals to, what is the first one? I have it as, okay, I have U of L divided by, this is, okay, U of L divided by what? U, which is, how do I get my U of, now, what I will just do is that, divided by, difference between this and this, which is, I have 3, it will be 3. It will be divided by 3. Now, to get this, just like I'm trying to what? I have it, which is, I have 10 minus 7, which is going to be 3 Newton. Now, which I will have it that way. It means I can say that my U of L equals to 1.3 multiplied by 3. 1.5 multiplied by 3. Which I will press my calculator. Now, with my calculator, I have it as 4.5 Newton. 4.5 Newton. Since I have it as 1.5 Newton, I will now move up by having obtruse equals to weight in air minus weight minus the weight in fluid, which is liquid, also. I can call it as liquid, anyone, because I'm trying to explain to some. Okay, now I can also see that my weight of object in liquid can be equals to weight in air, weight in here minus minus trust in liquid. That is very, very important. It means I can write it as well as of L equals to of water minus what? Uptrust of liquid. Which what I will have is that this will give me equals to 10 minus 4.5, which I'll be having which are the 5.5 Newton. 5.5 Newton. That is all I will be doing for now. All I'll be doing for now. You can see it's very simple once you have the formula at hand. Now I will be ending it here. Our next video will be problems on what? Equilibrium of body in liquid. Equilibrium of body in liquid. Don't forget that you are on with Further Solutions Academy. Further Solutions Academy. Please encourage us more to share, and also anywhere you see subscribe. If you have not subscribed before, help us to subscribe, and we need more of you contribute to this platform. No amount is small. Please and meet us on this number 48034495990. With this number, you can call us, you can WhatsApp us, and Telegram is allowed. Once again, thanks for watching.